Hi guys, I think I've discovered something fairly major for most people, and that is, cutting straight to the chase, is that the second stage precipitate from Dead Sea salt, that is coming up from pH1 to 8.5, is more than likely mostly magnesium hydroxide, bearing in mind that we've already discovered that there is something else in there. But it does lead us to the conclusion that the effects of the something else in there are being heavily diluted by the fact that there's a lot of magnesium hydroxide there. So in this experiment, two experiments in one really, then I was working out ways of getting the precipitation happen more slowly. So I started out adding pH 9 material, that is sodium hydroxide, and there's so little sodium hydroxide in a pH 9 solution that it takes volumes of it, and I did actually do it, and that's these three here, and the result was a little bit variable, but I produced a similar amount of precipitate. This one, you can probably see where you are, is very brown. I'm in the process of washing these out and draining them out now, and so I wasn't very happy with that result. It took gallons, litres of, and not much difference. So then I came up with the idea of trying to do it even more slowly and using a chemical bridge. So I made up this little chemical bridge, and what it is really a shoelace twisted together, and you can dip it in a sodium hydroxide solution here, and it will slowly diffuse and across into this solution here. So it's like a potential, really, like a potential bridge, a chemical potential bridge. And and also it's happening so slowly, there's no way I was going to stand there and stir it. So I've got a little motor and rigged up some old chargers here with the same voltage, and I made up a little stir. I'll probably post that separately. So this just fits in the jar. The edge of the jar fits in here, and it's just stirs. So I won't waste time talking about how I did that. But that enabled me to do it over several days. The first one here, this is the first bridge. This is the first one here. I said three, it's actually two. This is the first one here. Again, doesn't look very similar. That went quite quickly. I was gradually working out how to do it. This one went over a period of a day or two and produced a whole lot less. And then this one I produced over 8 days. Now nobody's going to stand there stirring for 8 days. And I've got I'll just try and bring it close, hopefully it'll self-focus. Just a very small amount, and it's actually lapping up the side, so there's areas on the bottom of that which were virtually precipitate free. Now this is the result after washing. On the left is the pH 9 solution that was added by that method. You can see it produced the most precipitate, that is the most magnesium hydroxide, you would say. And the best of the bridging method over 8 days produced the least, and the standard method on the right, which is the control, you can see there, produced in the middle. So not a huge amount different with the bridge. So what does it all mean? It means that you can't add sodium hydroxide slow enough to prevent the formation of magnesium hydroxide. So each of these samples, if they were then taken to pH 12, 12.1, much of this would be left there. You would virtually notice not very much of this would disappear. And on reprecipitation you get a lot smaller amount. That's indicating that there's a significant amount of magnesium hydroxide present. So my advice is the best way to do it is to take it up to pH 12 from the start. So now whether you need to wash it out at pH 10.6, 10.7, then I'll do some future work on that to do some comparisons, see if there's any better result. Anyway, enjoy the rest of the video and you might be able to duplicate this result for yourself. It has been washed 4 times and pH has been brought down to 1, and by maintaining at 1 you see that the solution will clear like this, and I've divided it in half. Now half of it I will put into these 3 jars, and this is what I've got going for the third sample. Then I've put it in the third container, filled it up to the top with water, and I've got the caustic solution there on the piggyback on the side. I don't know if you can pick it up, but I've got a few shoelaces, brand new shoelaces, twisted together and using that for a wick, so that the solution can bridge across, and so that will slowly bring the pH up as much more slowly than what I can do drop by drop. And of course I've got the automatic stirrer there, so I don't have to be stirring. I just made that out of a about $6 little thing I bought from off the eBay, and that's just a piece of a coat hanger, which I don't know if you can see down the bottom. I'll try and get you a shot from the top. Oh, there you go. And I cut that thing at the bottom on an angle so it will stir, and stir it from top to bottom as well as circular motion. And of course the pH meter fits in there. And for the power supply, then I knew the voltage, and so I usually keep my little power adapters, and while they're only got a very small milliamps, I put two of them in parallel together, and it seems to be working fine. So I expect I'll be leaving this for about 24 hours, and I'll just monitor where the pH is. I won't leave the meter on, I'll just come out and look at it from time to time. I don't know if you can pick it up there. It's sitting on 2.2 at the moment, coming up from 1, and I imagine that will come up very slowly. That went a little bit better than expected. I came out here this morning after I think about 20 hours tops, less than 20 hours, and the solution was cloudy, so then I turned on the pH meter, just get that in the frame, 10.4, so reaction's gone well past 9. Before I went to bed it was only sitting on 2.4. Now it does buffer, so it's hard to know exactly where you are. Anyway, all those bits of paper just to stop stuff falling into it, just a bit of glad paper. So I think I'm going to have to start again. I'll use the other half of the solution. The first half I divided into 3 and have done 3 different methods of this. So I think I'll divide that first half into 3, still keep 1 or 2 of them as the control, and redo this experiment again. At least I know how fast it goes. After 5 hours it was a little bit murky, and the pH was 3.5. Now a couple of hours later again, it was very murky. And if I can get my other hand in there, got pH 10.4, flashing 10.5 occasionally. So I failed again. Look, I'm just trying to work out why. Now, I do have a reasonably strong solution in here. It's 0.66, whereas I normally use 0.32 grams per mil. So it's 0.3233, so 64, 66. So it is stronger, and that's just so that the chemical bridge potential will work a little bit better. And you may not be able to pick it up in here, but the level in this is here, but you might be able to tell from the reflection here, that true level of that is about there. From you've got parallax where you are. So moving across here, we've got 50 or 60 mil potential in height as well. So that means that we're getting a siphon effect across here, which is what I'd hoped. If the levels were more even, then all we've got is the chemical bridge and the potential between the 2 different chemical concentrations, which means it will go slower. So what I think is happening is that I'm getting more of a siphon effect, and so the chemicals pushing through. If I have more of an even level, then we'll get an infusion. Okay, Mark 3, method 3. Succeeded in getting no precipitate at the start, so we're good to go. And the modifications I've made is I put a little 50-back jar instead of using a big jar, I realised that I could calculate the amount of sodium hydroxide normally sets a reaction off, and since I am using 1/6 of the original, and since I could calculate that I usually would use the equivalent of 12 mil, then if I put 3.5 mil into a solution, it's much more dilute of course, and allow all of that solution to bridge in, then I won't overshoot. And one of the other problems I thought I might have, the wick, I never properly washed that out, so I properly washed the wick out as well, and I've got my levels right, so hopefully if all that solution drains in, siphons in, then I shouldn't run over. It may or may not take longer, but our pH is starting out at 2.1. That's a bit out of focus there for some reason. Let me refocus that. 2.1. So who knows, might take a couple of days, but let's see the result this time. Been going about 9 hours overnight. You can see there's a small amount of precipitate swirling around in there. The pH is still sitting at, take the focus, 2.7. Actually, that's 2.5 if I can get a better angle on that. 2.5. It's been about 36 hours. Just trying to get a 2.7. Try and see if we can see what's in there. Look, it seems to me to be becoming milky, I think. Day 5, slowly, 4.4 pH, and you can't really see it, but it's very fine precipitate in the solution. But that little white lump there, that's where the wick comes out, and it seems like there's a build up on that, so I'll probably carefully take that out and not include that. Day 6 sitting on an 8.2, it's near the end of the day. Day 7, 8.4. End of day 8, finally at 8.7. If it looks still pretty normal. I'll just gently scoop that wick out that seems to have that growth on it. I might leave that as part of it. Finally have something to compare. After 8 days, the third bridge sample has finally reached pH 8.7, and straight away I can see a couple of differences. First of all, it's darker, and you will also notice that the middle one's darker, and I suspect that this is dye coming out of the bridge. Second sample took longer than the first, and of course the third sample, which is darkest, took a very long time, 8+ days. The next is, if you can see the amount of precipitate in the slow one is very small amount. Now I haven't really properly settled that because it came off the stirrer, but the solution's pretty clear apart from the colour. I suspect that there's not going to be much more compared to the other two. Now, in terms of not much difference in these, in the amount, but you wouldn't say there's an order of magnitude between the time, whereas there is in this one. The middle one was longer, but not dramatically longer like this one was for the reaction to take place. So I'll just let it settle a bit more and have another look.